Welcome to the video lecture for section 2.1. This is for MGF 1106. My name is Jorge Gavillon. And so section 2.1 is the first section that we're going to cover in this course. This is a language of sets. And so the objective is to specify sets using both listing and set builder notation, understand when sets are well defined, use the element symbol properly, and then find the cardinal number of sets. And so representing sets. A set is a collection of objects. An example would be the set of students in this course, the set of students at PHSC, the set of people who live in Florida. Those are all sets. And an element is a member of a set. So the first example, the set of all students in this course would be each individual student would be an element or a member of the set. Set builder notation representing sets again. So the way that we read this is set C is equal to the set of all X such that, now instead of a colon, sometimes they just have a bar, a vertical bar, such that X is a carnivorous animal. And so this is how you read in set builder notation. So a set is well defined if we're able to tell whether any particular object is in fact an element of that set. So we're going to determine whether a set is well defined or not. Which sets are well defined? Set A is equal to X such that X is a winner of an Academy Award. And then B, T is equal to old X such that X is tall. So we can see that the first one is well defined because we can always determine whether or not a person belongs to set A. And so it is what they call a finite set, and we can literally list all of the Academy Award winners. Now, for set T, whether or not a person belongs to this set is really a matter of perspective and how do you interpret the word tall. So therefore, T is not well defined. Can you think of one situation in which a person who is 6 feet tall would be considered tall, and a different situation where that same person might be considered short? Perhaps the NBA would be one such example. The next thing is a set that contains no elements is called the empty set or the null set. The set is labeled by the symbol here given. Another notation for the empty set would be just two braces with nothing inside. So here's another example using similar notations precisely. So thus the set that contains the empty set have the same meaning as the empty set, and do the set that contains the empty set and the set that contains zero mean the same thing. So for A, note that the set that contains the empty set is not the same as the empty set. To make this more clear, you might think of a set as a paper bag that you may get at a supermarket. Then the empty set corresponds to an empty bag, whereas the set that contains the empty set could be visualized as one bag containing a second bag, and that bag being empty. And then for B, the set that contains zero is not the same as the set that contains the empty set. If we make the bag drawings, then we see that the set that contains the empty set corresponds to a bag containing an empty bag, whereas the set that contains zero corresponds to a bag containing the number 0. The next thing is universal set is a set of all elements under consideration in a given discussion. We often denote the universal set by the capital letter U. I should say we always denote it by the capital letter U. So consider female consumers living in the United States. So the universal set would be X such that X is a female consumer living in the U.S. The next thing is the element symbol. The first symbol means that something is an element of a set. The second symbol means that an element is not it's not an element, or something is not an element of the particular set. So here we're going to replace the symbol in each statement by either it is an element or it's not an element. So here we have A, B, C, D, and E. And so 3 is in fact an element of the set that contains the numbers 2, 3, 4, and 5. The set that contains number 5 is not an element of the set that contains the numbers 2, 3, 4, and 5. And the reason being is that the set that contains the number 5 is a set itself. And then the second one on the right-hand side is a set, but it just contains elements, so doesn't contain any sets. Bill Gates is an element of the set of billionaires. Jogging is an element of the set of aerobic exercises. The Ace of Hearts is not an element of a face card in a standard 52 card deck. Cardinal number The number of elements in the set A is called the cardinal number of set A and is denoted by the symbol n in parentheses A. A set is finite if its cardinal number is a whole number, an infinite set if one that is not a finite set. So just n reminds us of the word number, and capital A reminds us that we're dealing with a set. So state whether each set is finite or infinite. If it's a finite, state its cardinal number using the symbols. And so set P, X is a planet in our solar system. Set N, set A, the empty set, and then set X. So the cardinal number for P is 8. The cardinal number for N is a set of counting numbers, so this is an infinite set. Set A is a person living in the United States who is not a citizen. So there are a finite number of people living in the United States who are not citizens. However, we probably do not know what the actual cardinal number of A is. The empty set has no elements, so it's a finite set. Thus, the cardinal number of the empty set is 0. And then for the last one, set X contains 3 objects. The set that contains 1, 2, 3, the set that contains 1, 4, or 5, and the set that contains 3. So therefore, the cardinal number of set X is 3. And that's the end of 2.1. Thank you.